Okay, here's problem number 13 from 9.5. What do we got in terms of trying to show convergence or divergence? Well, n's going to get big. What about sine of 1 over n? What's going to happen with that? It's going to go to 0. Because as n, 1 over n goes to, 1 over n will go to 0 as n gets big. And so sine of 0 is about 0. So it looks to me like we got a tussle. One thing's going to infinity, one of them's going to 0. Who's going to win? Why don't we find out? Let's see whether, it could be that this expression, it could be that the natural log, that it could be that as n goes to infinity, n times sine over 1 over n goes to infinity. It could happen. In which case, this problem is relatively easy to do. If the terms keep on getting bigger instead of smaller, the series end up being divergent. Let's try that. Let's see what happens. I don't know. I say that this is indeterminate in the form infinity times 0. Too bad it's not L'Hopitalable. Ooh, yes. So what are we going to do? Let's make it L'Hopitalable.
How do you have to make it L'Hopitalable if it's 0 over 0?
0 over 0 and infinity over infinity are the two L'Hopitalable forms. So let's rewrite this as the limit as n approaches infinity of sine of 1 over n. And instead of n, I'm going to write this as dividing by 1 over n. Okay, when we do that, we're going to end up getting a 0 down here, a 0 on top. This is now in the indeterminate form 0 over 0, and now we may apply L'Hopital's rule. Okay? So let's give that a try. The limit as n approaches infinity, the derivative of the top is cosine of 1 over n multiplied by the chain rule, negative 1 over n squared, all over the derivative of the bottom, negative 1 over n squared. Somehow my n turned into an m. Hey, those two cancel. So now we end up getting, what is the limit of cosine of 1 over n as n goes to infinity? Well, n goes to infinity, this thing turns into a 0, it becomes cosine of 0, which is 1. Okay, this is not equal to 0. This diverges. Okay, so wait, therefore, well, I gotta write the series out. Therefore, the series, n times sine of 1 over n diverges by, and now we need the rule that we just used.
Nth term test.
The nth term
Wait, what?
test.
I got it up to here.
Okay, so what's going on? These terms are not getting closer and closer to 0. They're getting closer and closer to 1 as n gets bigger. If I keep on adding numbers in a series infinitely, and those numbers are big like 1, the series, the total sum of all those numbers, isn't going to be finite. It's going to keep on getting bigger and bigger and bigger. This series diverges.
So only if it's 0, then it...
Only if it's 0. Well, no, this is the best thing that we could have had happen here. If it's not 0, it's divergent. If it is 0, then we would have needed to use another test to try to figure out whether it goes to 0 fast enough in order to be convergent.
Oh, that's awful.
Okay. And I just don't... What's the nth term test?
The nth term test. The nth term test says this.
What lesson was it?
9.3, I think. If the limit as n approaches infinity of the nth term does not equal to 0, then the infinite series diverges. That's it. That's the whole thing. If you take its limit, it's not equal to 0. Right?
Got it.
Got it. All right. We good on 13?
Yeah.
Excellent. 13's done.